Welcome back. This is section 12.12, Rotational Inertia and Gymnastics. This is section 11.5 in your textbook. So we're looking at rotational inertia, and remember that wherever the mass is away from the pivot point, the farther away that the center of mass is, or where most of the mass is located, the farther away from the rotation point, the larger the rotational inertia. The larger the rotational inertia, the harder it is to get something to spin, or if it's spinning, the harder it is to stop that spin. Okay, so we're going to look at how this works in the human body as someone is in gymnastics doing all kinds of flippy turns. There's three rotational axes. There's the longitudinal, transverse, and medial axis. So the longitudinal would be like you spinning. So when we'll talk about ice skaters spinning, doing spins, that's along the longitudinal. Medial axis would be like doing a forward roll. Okay, and a transverse axis would be like doing a cartwheel. So how you spin would be depending on which direction your orientation of your body is spinning. If you have an ice skater that's going around longitudinally, and your arms are pulled in close, you have the lowest inertia because your body mass is all located towards the center, and it's easier to turn. If you pull your arms out, then some of your mass is actually farther away from the pivot, and so that larger inertia is going to make it to where it slows down, but once it's spinning, it would be actually harder to stop you. Okay. Then if you put your legs out, that's more mass than your hands, and so you can actually slow down even more. Then if you were to put your legs and your arms out, then you're even having more mass farther away from the pivot, and you would even be slower. So part of an ice skater's routine is to do fast and slow. So the harder it is to spin, the slower you're going to go. The faster you are, the easier it is to spin, the faster you're going to go. So manipulating your body back and forth is going to not just make you be able to spin, but spin with fast and slow tempo. The second axis is the transverse axis, and this would be like a forward roll. If everything is tucked in, like you learn when you're in gym class, when you're a really little kid, you can do a forward roll. Everything is tucked in, and it's easy to roll your body. If you were to extend part of your body and do a flip, so let's say you're jumping off of the diving board, and you're doing a flip this way. The farther away, say, your feet are from your pivot point, wherever you're pivoting, the inside of your transverse of the body, you're going to get a slower, higher rotational inertia. It's normally slower, but more powerful. Then if you extend both your arms and legs even more, if you do it as a full straight flip, then it's even more. It's slower, but more powerful. And then once you get up to speed, it's harder to stop. If you were to flip, say, from your hands, if your hands are the pivot, then your entire body is going around it. That is the highest rotational inertia you can have from your body. The lowest would be if everything is pulled in and tucked in close. So if you were to, say, go from A to B, actually flip off of the bar, you would be going slowly, and then immediately that same momentum is in your body. You can make yourself speed up in midair. If you tuck in your arms and legs, you would go from a slow position to a fast position all of a sudden with no apparent change in where the force is coming from. It's just a conservation of momentum. The last is the medial, and that would be like a front to back cartwheel, and you are extended out. So normally a cartwheel is very slow. You would not have a very quick cartwheel because your entire body is extended. So what are the three principal axes of rotation? Going around where you're spinning like an ice skater, where you're flipping like a forward roll, or you're sideways flipping like a cartwheel.